I'm going to start by differentiating y is x squared plus 1 to the power of 4. It's important to know the two different ways of doing it, the long way and the short way, because sometimes they will say show that that is, and dy dx is the answer, and you might look and think, well, I could have done that, but I can't really show it, and that's if you use a very quick way. So the long way you need to be able to do to show how to do it. So you start with saying u equals x squared plus 1. So y equals u to the 4. So you put a variable for the middle of the function. So this here is going to be our u. So you have du dx will be 2x, and then dy du is 4u cubed. Notice you've got y there, u's there, so dy du, u there, x is there, so du dx. So a final answer of dy dx will come from dy du times du dx. And you can see effectively if you're doing fractions, those two would cancel out and give you dy dx. So now dy du is 4u cubed, du dx is 2x. So it'll be 8x u cubed, or if you substitute your u back in, then you're going to have 8x times x squared plus 1 to the power of 3. And that's how to do it. So the quick method is this. I prefer to my students to put their finger, or in this case my hand, over the middle of it. So you stick that, you don't change that at all, and you imagine you've got something to the power of 4. So what's that going to be? Well, something to the power of 4 will give you that 4 something cubed, and you keep that thing inside, you don't change it. But then you multiply by whatever you've put your finger over, differentiated 2x, so it's going to be 8x x squared plus 1 to the power of 3. So you can see that is a great deal faster than that method. So let's do it again with a different example. So let's say y equals, do a fairly similar one, x cubed minus 2 to the power of 7. So doing it the fast way firstly, do the fast way this time. So you put your finger over the middle of it. You've got something to the power of 7, will differentiate 7, something to the power of 6, and you keep that inside. And you multiply by that differentiated, so you get 21 x squared x cubed minus 2 to the power of 6. Right, now the long way. So u equals the middle of it. So y will be u to the power of 7. Differentiate both of them with making sure you've got letters right. You've got u there and x there, so it's du dx, 3x squared. A y there and a u there, dy du will be 7u to the 6. And do say u to the 6 in your head. Don't say u6. Because if you say, for example, there's a little aside here, if you call this, if you say that's 2x, then the next line down that'll be 2x, the next line down that'll be 2x. That and that are very different. That's 2 to the x. That's 2x. That's u to the power of 6, or u to the 6. So we then lay out our chain rule formula. So dy dx equals dy du times du dx. We put them all together and we have 7u to the 6 times by 3x squared, which is 21x squared u to the 6. Substitute back and you get 21x squared x cubed minus 2 to the power of 6, which is here the same as you'd expect as you're doing the quick method. Let's do another one. Let's say we've got the natural log of x cubed minus 4. So the quick way is, and do write down dy dx when you're doing this. It's very easy to forget that. This means the height of the function, the y value, when you put in a certain x value. This means the gradient of the function, or the slope of the function, or how fast it's increasing. So you put your finger over that again. So ln becomes 1 over, so it's 1 over that. Times by whatever you put your finger over, differentiated. Then the long way is u is the middle of it. Whatever you, basically u is whatever you put your finger over. Y is x cubed, so du dx is 3x squared, dy, du, am I wrong here, sorry? That is a u, is u cubed. I'm wrong again. It's 3 u's. Okay, I've gone completely wrong here, sorry. Just to prove that I can't multitask, that's 1 over u. So y dx is dy du times du dx, which is 1 over u times by 3x squared, which is 3x squared over u, or 3x squared over x cubed minus 4. Again, the same as you got with the fast way. Let's do another one of these because they're quite important. So let's do another ln. Let's say it's x squared minus 7. I'll do the long way first. So u equals x squared minus 7. Y is natural log of u. And also when you're doing this, make sure you're writing y's and u's properly. If you're lazy and you write y's like that or whatever, they start looking identical and you're going to have real problems. So make sure your writing's good, please. So du dx is 2x, dy du is 1 over u. So writing out the chain rule formula, dy dx equals dy du times du dx, which is 1 over u times by 2x, so it's 2x over u, or 2x over x squared minus 7. Doing it the fast way, again, the centre of the function is that bit. So that's the bit that we put our finger over. So that's effectively like our u. So ln y is the natural log of u. So dy du will be 1 over, natural log differentiates to 1 over, so 1 over x squared minus 7 times by that differentiated, which is 2x. So it's 2x over x squared minus 7. Let's do it with an exponential function now. Y is e to the x to the 4 minus x, let's say. So this time, this is the centre of the function, the middle of it, as I call it. The first thing, if I gave you what's y when x is 4, you'd substitute 4 into there firstly and then e it. That's how the calculator, or you should do it if you're doing it manually or slower. So, put your finger over that. We know that dy dx will be e to whatever e differentiates to e. E to the x differentiates to the e to the x, so e to the u differentiates to e to the u. Times by whatever you put your finger over differentiated. So times by x to the 4x cubed minus 1. And remember to put that in brackets. If you don't put it in brackets, the e is just multiplying by the 4x cubed. You want all of that. Probably you write that with that at the front, but it's not a big deal, by the way. So, we now will obviously put u is the centre of the function, x to the 4 minus x. Y is e to the u. So du dx equals 4x cubed minus 1, and dy du is e to the u. So, writing out a chain rule formula, dy dx equals dy du times du dx. And to make sure your u's and v's, because we do use u's and v's quite a lot in maths, make sure that your writing of them is that's a u and that's a v. And if you're really unsure, put a little tail on it that way. If you write u and v, they can be very, very easily confused. They're not great letters to have chosen. I think mathematicians could have chosen two better letters like P and Q or M and N, but they don't. They use U and V. So we've got dy du is e to the u times by du dx, which is 4x cubed minus 1, and we substitute back. Maybe this time round I'll write it in the more general way where you put the this bracket here first, and then we'll get that.